Welcome to 90 Notes. Today's lesson, Standard Deviation. Well, this is following closely after our lesson on variance. Remember, just a little while ago, we talked about the variance of a small population versus a sample. On the left, well, we used mu for the average. On the right, we used x bar. On the left, we divided our summation by n, the number of elements in this population. And on the right, we divide by n minus 1, one less than the number of samples, or the sample size. So now, we're going to take both these equations. We'll take the square root of them. Yeah, you're probably wondering why we used a variable called sigma squared. Well, you said, I thought sigma meant something, and it does. It's standard deviation. Take this equation, take the square root of both sides, and you say, hey, I got standard deviation. Conversely, take the standard deviation and square it, and you've got the variance. Which one should you use? Well, that's going to depend. That's not the topic right now. Right now, we're just talking about how to use the standard deviation. I'll pause that video if you want to look at these and maybe jot them down, or maybe you've already got these different equations, these four equations. Well, then you can move on. And let's look at sneak peek. Okay, this is a sneak peek at the empirical rule, which is going to be a future lesson coming up soon. You will remember when we learned about these curves, these normal distribution curves, we said we can move that mean around, we could change this curve, we can make it flatter, we can make it steeper, and then we said there was a few other things about it. Oh yeah, what were they? Well, I think what we said, hang on, move that over one more. I think what we said was we've got these points of inflection where the curve changes direction. Now, if we were to plot these vertical lines right here, these lines would represent our standard deviations. And again, just you'll see this tomorrow in more detail. But what does it mean? Well, our 68, 95, 97 rules got something to say about it. Let's suppose I was going to, oops, sorry about that. Let's suppose I did this. Suppose I shaded this. Once I've gotten to, well, let's say one standard deviation, you can see that I could say the area under the curve. Well, that's 68% of the shaded area is 68% of the area under the curve, or I could say a 68% chance that a piece of data falls in that shaded region if it obeys this normal distribution curve. Let's keep that going. And as you can see, or as you probably figured out, by the time we hit these blue lines here, which represent two standard deviations away, see, then we're going to be looking at 95%. 95% of the data is going to fit within there. Now that tells you that it might be handy to know a thing or two about standard deviation. So let's get to the tedious part. We're actually going to calculate one by hand. Okay, no TI-83s here. Ooh, no, yeah, we'll go back in time. Maybe we'll pull out your abacus and let's get to work here. We've got 8 samples that are made. So this is a complete population, normally distributed population. 8 samples of saline solution that you made. Maybe you're trying to sell something and it's going to be suspended in a saline solution. And we've got 8 different samples, and we measured them for salinity in parts per million. And then we're going to, let's see what the standard deviation is. So let's crank this one out. All right, first we've got to get an average. We're going to use mu for average. We're going to take the sum of the values and then divide by, well, the number of the values. Can we do that? Oh yeah. Let's bust out the calculator. Oh yeah, we got the old We got the old 4-banger. That's all we need. I want to add these numbers. You'll notice not a lot of sig figs on there. I'll take 3,700. I'll just enter 37 plus 41 plus 32 plus 39 plus 29 plus, I almost got lost, 32 plus 43 plus 27 equals 280. Hey, you got to remember to restore the hundreds. 280 hundreds, well, that's actually 28,000. In other words, just attach 2 zeros to the end, or append, an X, they say, I think, in grade school now. Now we've got something to work with. Now we can find the average. I should have done that with my calculator out here, because now I'm going to take this number, I'm going to take this 280, which is really 28,000. I'm going to divide by 1, 2, 3, 4, 5, 6, 7, 8, 35, or 35 hundreds, I should say, 3,500. So looks like we're set. So our average is going to be 3,500 parts per million. All right, and guys, now comes the tedious part. Yeehaw, we're going to make a little columns here. We're going to take the difference of each value. We're going to subtract the average from each one. Now, just for fun, I'm going to color code the signs. I don't know why. It doesn't really matter because we all know what's going to happen. We're going to square them and they're going to go away. So, and actually, maybe we can upgrade. Ready? Upgrade. Yeah. So, again, we got 37. Well, some of these we could do in our head. What do we got? 35 here. So we got 3,700. We're going to subtract 3,500. Maybe we better keep this. I better keep track of what I'm doing here. 37 minus 35 is 2. That's 200, right? Are you sure? 37 minus 35 is, of course, 2. 200. 200 squared is going to be 200. Yeah. So we're going to have. So we're going to have 200 squared. Yeah, I just had to make sure I was getting that right, keeping track of all those zeros. So that's going to be 40,000. Yeah, I think that was right. Oh, I'm tired at the end of it after all this work today. Let's see if I can get through another one without screwing up. So let's take 41 and we're going to subtract 35. So it's 600. 600 squared is 6. Well, 6 squared is 36. So this should be 360,000. 600, let me do that in my head. All right, and if you need to, you can always rely on the calculator. Let's take 3,200. I take 3,200, I'm going to subtract 3,500, and I'm going to get a negative 300. When I square that, it's going to be 90,000. Again, please excuse my dear Aunt Sally. You'll see that this expression is contained within the parentheses. So you're going to square the entire value, hence they'll all be positive. And, well, come on, you did that in variance. You know how this works. 3,900 minus 3,500, that's going to be 400. And when you take 4 times 4 is 16. But 100 times, well, say, yeah, 100 times 10 is 100 times 100 is 10,000. So you're going to have to make sure you got 4 zeros on the end there. So that's 160,000. Wow. Let's see. How about this one? 29 minus 35. That's going to be minus 600. Now we can go back to the calculator soon, but we'll mix it up because otherwise the video takes forever. And that's going to be the same as that. All right? Makes sense. So we've got 3,200 again. Hey, we've already done this one. So this one's easy, right? So you can just repeat that. Already had that. Now 4,300. Did we have 4,300 before? All right, let's go old school. I'm getting dizzy. See if we stuck with slide rules. we know our place value is a lot better. 4,300, and I'm going to subtract 3,500. And of course, that's going to be 800. And I square 800, I get 640,000. Okay? Now, when I take 27, hey, wait a minute. I take 27. I'm going to get the same thing here. I'm going to take 27 and I'm going to subtract 35 and negative 8, which another way of saying that, if I were to take 2,700, I subtract 3,500, I'm going to get negative 800. Yeah, 800 in the other direction. Just like this, I figure that some of these had to be above and some had to be below the average. I mean, since they are a difference. And when I square that, of course, this and this will be exactly the same. I like this. Gives you a visual that these two values are just on the opposite sides. They're equidistant from your mean on the chart, and they're just on opposite sides. That's kind of fun. All right, let's add all that stuff up together. And are we going to, where's that calculator? I'll go old school. How about, I'm losing track of this. Let's stick to thousands. Let's go 40 plus 360 plus 90 plus 160 plus 360 plus 90 plus 640 plus another 640. And what do you got? You've got 2,380, which is, and the remember to restore the or multiply times 1,000. You've got 2,380,000. Yikes! So I'm going to take that number and I'm going to divide by the number I have here, the number in my population. I'm going to divide by 8. Now I've got 297.5, and we remember what that means. Restore those values. There's 297.5 thousands. And then we'll take the square root. So anyways, that would be, by the way, that would, if you just take the radicand, that would be your variance. So let's do this, and while we still got it up there, shoot, I don't want to get lost, so I'm going to multiply times 1,000 to make sure we got that. All right, so there we go. That's 297,500. And we're going to take the square root. And it looks like we got 545. 545 parts per million. And that would be the standard deviation. All right. Well, that wasn't so bad, was it? Let's do I tell you what, we're going to do one more of these by hand. And that'll be it for this lesson. Next one. Okay. The winds and the aleutians. They follow a normal distribution, and boy, they blow hard. So we're going to take these samples, and we're going to find out. And again, we're going to say X bar here because this is a sample. So let's pull out our calculator, clear that bad boy off, and let's add these up. Now, thank God we're back to some normal numbers. 19.3 plus 26.8 plus 30.7 plus 25.7 plus 17.3 plus 37.9 plus 19.7 plus 32.7 plus 27. Oh yeah, plus 19.6. And I think what I forgot to add was the 0.3. All right, whew, that was a narrow save. So I got 257 on the dot. So that's going to be the sum of my x's. And then, of course, because we're getting old, we're old hat at doing averages. So we're going to say we've got 257 divided by 10. Well, that's easy enough. Move that decimal point over 1, and we've got an average. We're looking at an average wind of 25.7 miles per hour. That's pretty high. So, oh boy, you know what's coming next. Now comes the arithmetic. And this will take a little bit of time, but hopefully not too long. We're going to need the bigger calculator. We've already expanded because we need to do our square roots. So let's do it this way, 19.3, and we're going to subtract. Oh, wait, back up. I told you to do this before. You're going to do something repetitive, 25.7. Let's make sure the memory is clear. M plus, we're going to put this in our memory, 25.7. Now, I can say 19.3, okay, minus memory equals negative 6.4. Then I can square it. We're going to write those two down. Negative 6.4 and 40.96. Okay, well, this won't take so long. So let's move on to the next one. 26.8 minus memory equals 1.1. Hey, you know that's going to be 1.21, but there you go. So you remember your squares. Easy squeezy. Whoops. So I'm going to write down over there 1.1. And there's my square. Okay, let's hit it again. And let's take 30.7 minus memory, 5. Oh, can't go wrong with this one. Come on, do we need the calculator? I don't think so. So we're going to say 5 and 5 squared, 25. Now, 25 point, whoa. Hey, that one is right on the nose. That one is the average. I think I'm just going to fill that in with a 0. 0 squared, well, that's going to keep 0. Look at that. Saved your calculator some work. 17.3, let's go. 17.3 minus, we're going to use our memory, equals negative 8.4. Square it, 70.56 or 56 hundredths. So let's write that down. Negative 8.4, 70 and 56 hundredths. Okay, 37.9 minus memory equals 12.2. Square that. 148 and 84 hundredths. Only a couple more. 19.7 minus memory equals negative 6. Well, this one we can handle. Negative 6. Easy squeezy. 6 squared, negative 6 squared, 36. Okay. 32.7. Hey, these 0.7s are nice. 32.7. Let me see. We already know we don't need a calculator for that. That's 7. 7 squared? Well, heck, that's going to be 49. Let's try another one. 2 more. 27.3. And we're going to subtract memory equals 1.6. And you all remember that square? 256. 2.56. Oh, almost there. So 19.6 minus memory equals negative 6.1. We square that, and there you go. Okay. Well, remember, we don't add up this middle column. We're going to have to add up the other column. And let's, oh my gosh, let's pull up our calculator. We've already got, we don't need that big, we just need the little guy for this. And we're going to add, well, we already got the bottom one in the register, 2.56 plus 49 plus 36 plus 148.84 plus 70.56 plus 0 plus 25 plus 1.21 plus 40.96 equals 411 and 34 hundredths. So let's put that in there. And we're going to tally up that column. And now we're ready. We're just about ready to fill in the blanks. Now, in this case, n minus 1. N minus 1 is now going to be 9. So let's divide this by 9, then take the square root. And we'll see how that goes for us. Let's see, we divide by 9. Ooh. And then, we're going to need the bigger calculator anyway, because then we're going to take the square root to the nearest tenth. And I guess we're going to call that 6.8. So there you go. We've got our variance and our standard deviation. Well, hey, that was fun, but one last parting thought before let's give a little picture of this. And since this is something you can relate to, the wind, the wind was blowing really hard last week. So what does this really mean? Let's take a couple of these numbers. Let's take this number and let's take this number. And let's go back to our graph. I'm just going to paste these numbers over here because I think we're going to do something with these two. What can we do with that? And again, I don't really know what this graph looks like, but maybe it looks like that. Does it look like that? Now let's say it looks like that. Well, we do have our average. And then we've got our 6.8. So you're going to take 6.8 to the right. Then you're going to take 6.8 to the left. What can you add 6.8? Well, let me see. If I were to add this, I could take 25.7. I'm going to add 6.8. Take 25.7, subtract 6.8. What does that mean? Well, imagine, just like we said before, what that means. You could say, according to this empirical rule that we'll see in more detail tomorrow, that if this wind is truly obeying this, you can say that you've got a 68% chance that the wind is going to be between, just under 19 miles an hour and 32 miles an hour. 68% chance. Wow. Well, add another 6.8. Subtract another 6.8. And then we could say, well, you'd probably say, heavens to Murgatroyds, the odds are 95%. Look at that, 68, 95. 95% that the wind is going to be greater than 12 miles an hour. Well, roughly between 12 and 39 miles an hour. That's a lot of wind. So that's a little bit of an application. Okay, some of that's a little bit made up, but I think the average is realistic. And the other data points, I made those up. So I hope you had some fun plotting this. And if you're in my class, make sure you turn your notes in. That's where you get your credit. And if you're not in my class, well, thanks for joining us. And thank you for watching Naughty Notes.